myself Dr. Divya, Assistant Professor at Department of Chemistry, Institute of Aeronautical Engineering. Today we will continue the session on outcome-based education for CO-PO mapping for Module 2 and 3. So by end of this lecture or the session, we will be able to understand the course syllabus and the course objectives, course outcomes, and also understand the course outcomes mapping with the program outcomes and program specific outcomes. So then justification for COs like with mapping, then key competences for CO, PO mapping, and percentage calculation for key competences for CO-PO mapping, and course articulation matrix of module 2 and 3 for the chemistry subject. So here is the content. First we will see a overlook on syllabus. What is the syllabus? Then course objectives, then course outcomes, then module 2 and 3, how the module is being designed, then course outcomes, program outcomes for module 2 and 3, then CO mapping with the PO and PSO, then justification for COs with PO and PSO mapping, then key competences that are being mapped for CO-PO, then percentage of key competences that are calculated for CO-PO mapping, and then the final one is the course articulation matrix for that particular modules 2 and 3. So if you see the syllabus, module 1 is the electrochemistry and batteries that we will be studying, then module 2 is the water technology. So we have seen in the last session for CO-PO mapping of module 1. Now let us see the module 2 and 3. So what is the third module? Engineering materials, that includes polymerization reaction with mechanisms and different polymers that are in wide usage. Then module 4 is green chemistry and fuels, that describes the green chemistry and synthesis, then classification of fuels. Then module 5 is the natural resources and environmental pollution, which gives a classification and resources, living, non-living resources, and the benefits and the non-renewable energy sources, renewable energy sources, etc. So with this is the 5 modules we have in chemistry that is being taught for the BTech freshers. So with that, like we have already seen the CO-PO mapping for module 1. So let us go in details for mapping on module 2 and 3. So students will be able to, the course objectives will always start with the phrase. The students will be able to do the concept of electrochemical principles and causes of corrosion in new development and breakthroughs efficiently in engineering and technology. And the second one is the second module. From second module, the different parameters to remove the causes of hardness of water and the reactions towards complexometric method or titration. And the third one describes the polymerization reaction with respect to mechanism and significance in industrial applications. And the fourth one gives the significance of green chemistry to reduce pollution in environment by using natural resources. So these are the 6 outcomes, course outcomes, 6 course outcomes for chemistry. So what are those? The first one gives the explanation on electrochemical principles, corrosion process for metals and protection for different metals from corrosion. So what are we going to get information here? We are understanding the topic. So depending on our understanding, we will be applying some formulae in calculating. So we are utilizing the knowledge of electrochemistry and its parameters and calculate the surface area, then current over potential and a given condition. So this is where applying our knowledge from the Bloom's taxonomy. If we observe understanding, then applying, these are 2 major important one we are applying in the chemistry part. So course outcome 3 is the identification, that we are identifying the cause for the hardness of water, and then apply the knowledge for calculating the hardness of that particular water, which can be used to avoid damages to the boilers, for example, if we are using in the engineering fields. So course outcome 4 gives a comparison of polymerization reaction, mechanism of lubrication with utilization in industry. So this is an understanding for us to know the knowledge, like so that we can apply in practical world. Then in the course outcome 5, green synthesis methods are being taught and different types of solid, liquid, gaseous fuels in terms of calorific values. So we are going to determine the calorific values. So we are applying the knowledge. In the course outcome 6, there are different resources that will be outlined and their applicability for understanding the effects of pollutants on air, water, soil, and that cause the environmental pollution. So we are learning out of this, so it gives an understanding. So out of these, 3 course outcomes are understanding and 3 are applying. 3 are applying knowledge for problems analysis. So that is what is given here in this graph. 3 modules or 3 course outcomes are for understanding and 3 are for applying. So this is how we describe the Bloom's taxonomy's levels in different modules in chemistry. So coming to the program outcomes, the program outcome 1 gives the engineering knowledge, wherein we are applying the engineering knowledge of mathematics, science and engineering together, the fundamentals of all together, and an engineering specialization to solve a complex engineering problems. So for any complex problems to solve, it is very important to have knowledge on mathematics, science and engineering fundamentals to move ahead in solving that problem. And PO2 or the program outcome 2 describes the problem analysis, wherein we having the knowledge of all these 3 will be imparting or inculcating those knowledge in formulae, and so that we can remove the hurdles during our analysis. So in that, as a part of that problem analysis, we are reviewing literature, then analyze complex engineering problems, reaching sustained conclusions using first principles of mathematics, natural sciences and engineering sciences. So if we see, these 3 are very important fundamentals of mathematics, natural sciences and engineering sciences. So in solving the problem, so that comes under program outcome 2. Then chemistry also comes under PO, can be mapped for PO7, which includes the environment and sustainability. If we see the last module, these 2 comes under environment and sustainability. So therefore, they understand the impact of professional engineering solution in societal and environmental contexts, and demonstrate the knowledge of need for sustainable development. So this is how we will be mapping this particular program outcomes with the course outcomes. The strength is calculated, so we will see in detail with how this strength is calculated, and which indicates the importance of that particular topic. So the PO1, if we go in detail, it applies the knowledge of mathematics, science, engineering fundamentals and engineering specialization to the solution of complex engineering problems. Then knowledge, understanding and application of scientific principles and methodology, mathematical principles, own or other engineering discipline to integrate, support study of their own engineering discipline. It means that these 2, the first and third one, includes in theoretical part, theory that we are studying. However, when the second one, it includes the problems. Second one, 1 and 3, theory. Second one includes problems, because we are using some mathematical principles in solving those problems. So this is how depending on the module, wherever the module is having problems, this PO1 of 2 is also applicable. So problem analysis, PO2 indicates the problem analysis, that is, they identify, formulate, literature review and analyze complex engineering problems, reaching sustained conclusions using first principles of mathematics, natural sciences and engineering sciences. So knowledge of having all the 3 branches is very important for any problem solving. So these includes key competences. These are key competences. Competences. What are the key competences present? Problem or opportunity identification. So we are identifying the problem. Then we are stating the problem and system definition. What is the problem? Then formulation and abstraction. Then information and data collection. We have to collect data depending for that particular problem. Then model translation. Then validation. We have to validate any method. Then experimental design for solving the problem. Solution development or experimentation or implementation, then interpretation of results that are obtained, and finally documentation. All these 10 competences are applicable for any problem solving module or the course outcome. So for example, if we are going to do like take the information like collection of the data, only then only 4 is applicable. If one, it means whenever there are 1, 2, 3 key competences are applicable, we quotize 3 for that particular course. So we will see in detail in the further slides. Then comes the program outcome 7. What is it? It is the environment and sustainability. So it will give us an understanding the impact of professional engineering solutions in societal and environmental context, and demonstrate the knowledge of and the need for the sustainable development. So this impact of professional engineering solutions is not really a technical one or the technical part of an engineering graduate, but it is also an important aspect to understand the socio-economic status, political and environmental aspects when we go for any particular applications. So then coming to the COPO mapping, it is very important to map the course outcomes with the program outcomes, because once the completion of course, the program outcomes will, the learners will come with the program outcomes. So identify the key competences of PO, PSO to teach course outcome. Make a corresponding mapping table with a tick mark. So at the corresponding table, for example, if there is a CO and the PO has to be mapped along with the CO, so the applicable PO will be marked with a tick mark. So one observation is to be noted that first 5 POs are purely technical and the next others are non-technical. So depending on the modules or the course outcomes we have, they have to be ticked properly. So justify COPO mapping with a justification statement. Recognize the number of vital features or key competences and then mention in the justification statement that are matching with the key attributes for assessing program outcomes. So use a combination of words COPO, PSO and the syllabus for writing the justification. So this is how we will be writing a table. So we will see in the next one how the PO-CO mapping is done. So finally, once the mapping is prepared, the CO-POs are measured on a scale of 0 to 3. So if it is 0 to 3, there is no correlation. So therefore, it's given a hyphen, then 1 being a slightly correlating, then P2 being a moderate or mediumly correlating with the COPO mapping, and 3 being a sustainable and highly technical, that is being correlating in a high aspect with the COPO mapping. It means whenever there are all the key competences are matching with that particular course outcome, then it gets more than 3. It means it is having high importance. So for example, if you see the module 2, water technology in chemistry, it is the course outcome 3. It will identify the hardness of water by different treatments for finding the hardness of water causing salts in water. So that we are applying some mathematical calculations. We are doing some mathematical calculations. So we are applying our knowledge. So it is in the apply level from the Bloom's taxonomy. So if we take the POs, it matches with the first PO, second PO, because we are imparting the knowledge, engineering knowledge, and then using it for the problem analysis. So it is therefore matching with PO 1 and 2. So if we see the justification, PO1 is nothing but treatment methods. We are learning the treatment methods to produce soft water from raw water for solving engineering problems by applying principles of science. So it is matching with two key competences. What are the two? Because we are explaining, so and we are using the principles of sciences. So PO2 is the identify the problem of information and data, then applying this for calculating the hardness. So it is also matching with two competences, key competences. So here we will see in detail. The first one includes engineering knowledge for the PO1, wherein scientific principles and methodology. We see here explain is nothing but methods. So we are taking the methodology part, then mathematical principles, then other disciplines to integrate, support their own study or the discipline. So these are the three key competences that are matching. Key competences that are matching with PO1. So 3 is given here, 1, 2, 3. 3 is given for the first PO. Then PO2 problem analysis. In problem analysis, there are around 10 key competences, but only 2 are matching for our module. So what is that? Problem or opportunity identification and information and data collection. So 2 are matching with our course outcomes. So we are giving 2 here. So this is how we map the program outcome with the course outcome. Then the percentage calculation of key competences. So these are three are matching, 3 competences are matching with 3 of them that are present. So 3 by 3 is into 100 is like 100%. So we got 100%. So here there are 10, but only 2 are matching here. So we get only 20% here. This is how we calculate the percentage of key competences for COPO mapping. Then coming to the module 3. Module 3 includes the engineering materials. So for any engineer to have practical applications when going for professional jobs, they should have idea on materials what they are using in production plants. So it is very important to know their classification and the mechanism how they are forming and their degradability and all. So this module includes that, and this course outcome gives a comparison of these polymerization reactions, mechanism of lubricants that are used. The lubrication mechanisms are of different types depending on the applications in the industries. So this gives an understanding. So the engineer should have an understanding of what is going on in the production plant, even at a lower scale, so that he'll be able to manage and supervise. So this gives an good understanding of how the polymerization reactions are taking place and how they are utilized in industries. So this, because we are only imparting knowledge, it only maps with the PO1. So only PO1 is ticked for course outcome 4, that is engineering materials. So this will in detail, if we see, it illustrates different methods or the types of polymerization reactions for synthesizing polymers from monomers. So different types of lubricants used to reduce the friction in machines working under different temperature conditions by using the principles of sciences and engineering problems. So it is mapping with the PO1 only. So it matches with the 2 key competences. Therefore, it is given 2. So if you see what are those 2, because scientific principles and methodology that we are knowing or learning, then own or other disciplines to integrate or support study of their own engineering discipline. So we are comparing with chemistry reactions that is going on. So that is giving a supporting study from the chemical sciences. So we are matching with 2 of the key competences from the PO1. Therefore, only 2 is given here. So no mathematical problems are involved. So only 2 is given, and course outcome is mapped with 2 of the key competences for the program outcomes. So therefore we get only 66% of the program outcomes that is being matched with the course outcome. So if you see overall PO PSO mapping for the specific outcome, if there are 6 course outcomes, so there are 3 matching for the first PO or the program outcomes, then 1 is matching for the second one. Like for the problem analysis, only 3 modules or the course outcomes have problems, therefore it is given 1 here in the second one, and third one, and then fifth one. So here these are the only 3 course outcome that is involving with problems, therefore they are marked for the second POs. And in the 7th, environment and sustainability, there are 3 competences that are matching for module 5, including the green chemistry, and for example, course outcome 5 including the green chemistry, and course outcome 6 that is for the natural resources, with 3 key competences that are matching for the program outcomes. Therefore, it gives an overall average or total of 6 and an average of 3. This is how we determine the COPO mapping, and this is the course articulation matrix that is being designed. So finally, if we are comparing with the scale that is being given, it is falling from 3 to slightly higher than 3. So if we see 1 being the slightly correlation, 2 being the moderate correlation, 3 being the highly sustainable correlation for the following strategy. So if it is 3, it is most widely applied or important in studying for further and future applications. So it is 3 that is coming out as an average. So this is having highly important or substantial high importance, and whereas 1 is slightly important in problem solving. So that is how the course articulation matrix is designed and decided the outcomes that are being important, so that learner will have an understanding how the planning will be better for the further study. So in this discussion, we have covered the syllabus of chemistry, engineering chemistry, course objectives, course outcomes, module 2 and 3, then course outcomes for module 2 and 3, then program outcomes, then CO mapping with PO and PSO, then justification of CO, PO, PSO mapping, key competences that are covering for the COs are the course outcomes, and the percentage of key competences calculation for CO, PO mapping. So this is how the different course outcomes are mapped. So in the next session, we'll move on to the different modules. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.